Hello, calculus fans. Let's talk about divergence now. Now, before we go on, let me make sure it's clear that this type of divergence is very much different from the type of divergence that you learn in one variable calculus. There's the divergence of a limit, there's the divergence of a series. This has nothing to do with that. It's another one of these cases of math people using one word to describe more than one thing. Let's suppose you have a vector field F, which has components P, Q, and R. This is a vector field defined on R3, and let's suppose that the partial derivatives of P, Q, and R exist. We're going to define the divergence of F is going to be the function of three variables defined by this. It's dp by dq plus dq by dy plus dr by dz. That's going to be the definition of the divergence of F. Notice that curl of F is a vector field, but the divergence of F is a scalar field. So they output two very different types of things. We can go ahead and use our del operator. We'll write the divergence of F symbolically as the dot product of del and F. So the divergence of F is simply del dot F. So it's going to be important that we keep straight the types of things that we have. We have the gradient of F. That's del applied directly to a scalar field. There's the divergence of F, which is del dot F. There's the curl of F, which is del cross F. Let's do an example. Let's suppose that we have this vector field. So 5xzi minus arctangent of xyj plus x squared y over y arc cosine 3x plus y cubed k. Let's compute del dot f. I would like you to be able to go back and forth between the del dot f and the divf notation for the divergence. So the divergence of f is the partial derivative with respect to x of 5xz plus the partial derivative with respect to y of negative arctangent of xy plus the partial derivative with respect to z of x squared y over y arc cosine 3x plus y cubed. Now at first glance, the third term, this looks terrible. But if you look closely, it's not as bad as you think. Because check it out, there's no z in there. That means the partial derivative with respect to z of that expression is nothing. Woohoo! So the partial derivative of the first term will be 5z, because we're differentiating that with respect to x. And the second term is going to be negative x over 1 plus x squared y squared. Notice the resulting expression is a scalar expression. There is no vector involved here. Now, let's talk about the reason for the name. The reason for the name divergence is, again, best understood in the context of fluid flow. Let's suppose that you have a vector field, which is the velocity of a fluid or a gas. Then the divergence of F will represent the net rate of change with respect to time of the mass of fluid or gas flowing out of the point xyz per unit volume. So in other words, the divergence of F measures the tendency of the fluid to diverge from the point xyz. If the divergence of F is equal to 0, then the vector field F is said to be incompressible. Okay, that's all for now.